This video presents the sysctl in pods control feature in OpenShift. For example, the net.ipv4.ipLocalPortRange sysctl allows to define the local port range that is used by TCP and UDP traffic to choose the local port. For example, the net.ipv4.ipLocalPortRange sysctl allows to define the local port range that is used by TCP and UDP traffic to choose the local port. There are a few categories of sysctls. For example, the kernel sysctls for kernel-related settings, the FS sysctls for file system-related settings, and the net sysctls for network-related settings. The network sysctls can be defined at two levels. One is the global level, where a sysctl is defined system-wide and will be applied to all network interfaces. Net.ipv4.ipLocalRange is an example of such a sysctl. A second kind of networking sysctls are interface-level sysctls. These are sysctls defined separately for each network interface. An example of such a sysctl is sys.net ipv4 conf eth0 except local, which is specific for the eth0 network interface. Some sysctls are namespaced. This means they can have different values in different namespaces. Here are some examples of namespaced sysctls. Namespaced sysctls allow to use custom sysctls within containers. Note that only sysctls that are namespaced can be set independently on a container. OpenShift allows to control the namespaced sysctls in pods. For the networking sysctls, both the global and interface level sysctls can be controlled. The global sysctls and the interface level sysctls are set using two different features: the pod security context for global sysctls and the tuning CNI for interface level network sysctls. Let's first look at the global sysctls. They can be set using the pod security context feature. Note the security context section in the pod definition. Inside it, we have a sysctls section containing a list of sysctls we want to apply. We start the pod and after a while we see that it's running. We now check the value of one of the sysctls inside the pod. As we see, the value corresponds to the one in the pod definition. Note that only a subset of sysctls can be controlled this way. These are the so-called safe sysctls. By default, this list only includes the following items. Additional sysctls can be added to this list by the cluster administrator. Let's now define a pod with an unsafe sysctl. When the pod is started, it ends up in a sysctl forbidden state. The pod status message will contain more information about the cause of the failure. The pod security context cannot be used to create interface-level network sysctls. At the moment of pod creation, the network interfaces are not yet created, hence there are no sysctls to set yet. Tuning CNI is a CNI meta plugin allowing to control interface sysctls and some other interface attributes. As a meta plugin, it must be used in a chain with a main CNI plugin, which creates the network interface to be modified by the tuning plugin. The tuning plugin itself does not create any network interfaces. In order to use the tuning plugin, an appropriate network attachment definition has to be created. Note that the network attachment definition has two plugins defined. First, the main plugin that creates the network interface, and the second is the tuning meta plugin acting on the interface created by the main plugin. Note the ifname token in the sysctl name. It will be replaced with the actual interface name by the tuning CNI at runtime. Next, we create a pod with the network attachment definition. Note the network annotation. Let's now create a pod which uses the network attachment definition we have created. Once the pod is running, we check the sysctl value. Note that the ifname token is replaced by the interface name. Let us now look at the unsafe sysctls. We will create a network attachment definition containing an unsafe sysctl. Please note the key on the sysctl. We now create a pod definition using the created network attachment definition. We now attempt to start the pod. Note that the pod will be stuck in the container creating state. This happens because the tuning CNI plugin returns an error, making it impossible for openshift to create the pod successfully. We will now look at the log of the CNI plugin. It is accessible in the kubelet log on the node. First, we need to verify on which node our pod is running. Once we verify that, we can access the node. On the node, we need to run the change root command. Once done, we can run the journalctl command, filtering by the kubelet unit. The logs should contain log messages from the failing tuning plugin. Scrolling the logs to the right, we will see that it complains about our sysctl key not being allowed.